So, grade 9, chapter 4, this is 4.1, writing equations to describe patterns. So what we do is we have a picture here. So if you look, this is a table. How many people can sit around the table? So we can put one on each side. So 4 people in this one. We put 2 tables together, we can have 6 people around. 3 tables, we can have 8 people around. So describe the pattern in words. So as you increase the number of tables by 1, the number of people increases by 2. Simple breakdown. You could do it as a table of values. Tables and people. So 1 table 4, 2 tables 6, 3 tables 8, and you can continue the pattern up. Then you can create what's called an expression. An expression doesn't have an equal sign in it. So define your variable. So t equals tables. You can use any variable you want. So 2t plus 2. And you can check that if that works. For instance, table 3, 3 tables. 2 times 3 is 6, plus 2 is 8. Yeah, that works. Now we can create an equation. So now we're going to have an equal sign. So p equals people, t equals tables. So the 2t plus 2, all it does is equal the number of people. So what happens if you have 13 tables? So t equals 13. You take it, plug it into the equation. 2 times 13 plus 2, so 26 plus 2 is 28. So we can use that. We can create the expression up here without the equal sign, and then we can turn that into the equation, and then we can use it to answer any question. All right, go to the second page. So this one is garden plot. So what we're going to do is we have boards, and we're going to make a garden plot. So we have 4 boards here, and we can make 1 plot. With 7 boards, because we can stick them side by side, we can make 2 plots. With 10 boards, we can make 3. So let's do the same thing again, describe it in words. As the garden increases by 1, the boards increase by 3. You can see 4, 7, 10. Do a table of values. Garden 1 has 4 boards. 2 gardens have 7. 3 gardens have 10. Okay, let's create an expression. Define the variable. G equals gardens. You can use any variable you want. 3g plus 1. And you can double check if that works. So garden, let's say garden 4, right? So 3 times 4 is 12 plus 1 is 13. Yeah, you need 13 boards to do it. Then we can create the equation. B equals boards. B equals 3g plus 1. So there, the expression, no equal sign. The equation, equal sign. So now what we can do is we can ask questions. How many boards are in 12 gardens? So 3 times 12, we just plug in, substitute in 12 for g. 3 times 12, 36, plus 1, 37. We need 37 boards. We could also go the other way around. Hey, what if we had 28 boards? How many gardens could we make? So we do the math here. So 28 equals 3g plus 1. Well, how do we do that? Subtract 1 from either side, and we end up with 27 equals 3g. How do we get g by itself? You divide both sides by 3. You can find out you can make 9 gardens. So once you have the equation, you could go either direction and solve for either one of those. Okay, last page, Kelly's calves. So Kelly's cabs is an interesting example. If you've ever been in a cab, you know that there's a fixed cost for getting in the cab. So in this case, the fixed cost is $3.60. So if you go 1 kilometer or 100 kilometers, the fixed cost is still the same. And then so much per kilometer after that. So let's define some variables. D for distance, C for cost. You can use anything you want. Create a table of values. If you go 0 kilometers, I know that seems silly, but if you get in the cab and then get out of the cab, you still got to pay $3.60. What if you go 1 kilometer? Well, it's $3.60 plus an extra $1.50, and then 2 and 3. So create an expression. So here it is here. $1.50 times the distance plus $3.60. There's your expression. Turn it into an equation. Yeah, that equals the cost of a cab ride. So you can use that equation now to figure out how much it would cost for an 11-kilometer taxi ride. So there's the formula. C equals $1.50D plus 360. You're going to replace D with 11 because that is the distance. So $1.50 times 11 and then plus 360. Your total cost of the cab ride is $20.10.